All right, let's go ahead and get started. Hi, everybody. How are y'all doing today? Everybody making progress on their program? Any questions you'd like to ask me before we get started? No? Okay, let's go on. Any questions? Yes, sir. Yes? Yeah? Other questions? Yes, sorry. So the question was, do you have to have a default statement at the end of your switch statement? And the answer is no. You only need it there if you think there's going to be a chance that you're going to get something that you're not expecting. So if you are switching on something that you know is from a constrained set of values, there's no point in putting a default there. You can just do it to be cautious and then catch some errors that way, but it's not required. Yes? Do you need to have a switch statement, like in your program? I don't think so. So in this class, the way it's kind of divided up the work between the professors who's teaching the other section is I am writing all the assignments and he's taking care of the grading. There is a grading rubric posted that you all should have seen. If not, it's on Blackboard. And I don't believe there's a requirement that you use a switch statement on there. You can do everything with if-then. I use switch statements in mine. I don't even know why, but I like them. So, yeah. Yes. Any statement you have can be used inside any other statement in any combination you want. When I wrote my master's thesis, it was essentially a giant switch statement, like a huge switch statement that had like tens or hundreds of cases. And then each switch statement inside that had like another switch statement. And inside there, like each switch statement, there was a bunch of stuff. So yes, you can use statements inside statements in any combination your heart desires, as long as it expresses the algorithm that you're looking for. Other questions? And by the way, that's true for everything we learn throughout the semester. Everything that we are learning throughout the semester can be used when in combination with any other thing. So any statement of any type, if, switch, expression, mathematical, can be used with any other type of statement, essentially without limit. Yes? How much comments am I looking for in your program? Enough to make clear what you're doing. Your code can be what's called self-documenting to a point, which is if you're using good variable names, then it should be clear what's going on. But it's always nice just to put in some comments to explain what your algorithm is. If you're using any weird data structures, which we're not at the point we're doing that yet, stuff like that, it's nice to have comments. Yes, sir. Okay, so yeah, so the question was, in the rubric there's a comment saying no more than 100 characters per line. And what that refers to is when you're typing up your code, how long your sentences, essentially your code statements, get. Does that make sense? So you can imagine if you were writing in English and you were writing like, I don't know, name something you write. A tweet. Thank you. A tweet, you have how many characters? That's hardware mandated. Let's say we're writing something larger, like a book, a paper, I don't know, a sonnet, whatever you all write when you're not in here. When you write in English, it's nice to like format your text so that people are easily read, right? When we read, we normally read things that are on a rectangle, and the rectangle is oriented with a long axis up, and so the sentences aren't very long, right? Imagine if instead of writing on a rectangle, you decided to write everything on a roll of toilet paper, and you rolled out the toilet paper till it was like 20 feet long, and each sentence was 20 feet long, right? Would that be really annoying to read? You'd start it here, and you'd walk, and you'd walk, and you'd walk, and you get to the end, and you have to walk all the way back. So the same thing happens with code formatting, okay? It is considered polite to keep the width of your code below a certain amount. In the old days, that was 80 characters. Nowadays, people do like 100 characters, and then sometimes in IDEs, it'll let you go essentially as long as you want, and it gets annoying. So we're requiring that you keep your code within 100 characters, 100 characters wide. Yeah, so in the editor, it only shows the line position, not the character position. Your window, when you log in, will show you how wide your window is, like the whole screen. And so if you keep the screen to 100 characters and make sure nothing goes past the edge, you will make sure that none of your characters are more. Does that make sense? So, for example, so if you're on a Mac, I have it turned on up here. See this number up at the top where the cursor is? It says 78 by 25. I know this window is now 78 characters wide. It's an odd size. Like normally I worked with 80 or 100 or 120 just to keep it even. But for class, I just have like whatever random size shows up all on the screen. You can do the same thing if you're connecting over Secure Shell with a PC. There's a setting that tells you how wide your window should be. And if you keep your window width below 100 and keep your code from running out of the edge, you'll be fine. Sir? Handles any extraneous text after requested input. I don't know. Can you send me an email? I'll get back to you on that. That is the downside of having one person write the assignments and they'll do the grading. By the way, don't tell the other professor this. I got the way better end of the deal. I much prefer writing the assignments and doing grading. So he thinks he has a better end of the deal, though, so we're both happy. Any other questions? Yes? Yeah, so I didn't put it in the assignment. When you submit your assignment, just submit it as your netid.cc or .cpp, either one. No. Other questions? Just you can just, when you output, you can just output it as whatever you want. So if I say, you know, nano test.cc and I have some code, what I can do is I can do Control O and then see where it says file name to write. I can just output whatever file name. So I can change it to clay.cc or whatever. And now I've changed it. Okay, so in Nano, I did Control O for write out, and it says file name to write, and then I just backspaced and I put whatever file name I want, which is, you know, I don't know, like something. And then it says save under different name, and I just hit yes, and then it'll output. So okay. So it will overwrite your old one that's in your account. So okay, so let me give you the quick tutorial on what we need to do. So here we are, and we have all these different things. One of the things we can do all right, I just put that in there. You can do MV. MV is like move or rename a file, and you can move it from like netid.cc to whatever other file you want, like old project1.cc or something like that. The other thing, does that make sense? So you can rename files. The other thing is if you want, you can make a directory in on the machine we're working on. That's mkdir for makedir, and you can do something like p1, cd p1, and now we're working in a directory that we've created just for our project. So what you can do is on, you know, CS class, create directories for each project, cd, which is change directories into that directory, and then do all your editing there. You look startled. More hands are going up. I'm scared. Yes. Yes, you can also do other things. Yes, you can save it and submit it as another name. Just sure, netid p1.cc is fine. Here's what I care about. I care that you submit your code and we can download it and save it. And I want it, I don't want everybody to name theirs Framingham, because then there's a chance that like everybody's code will write on top of each other and there'll only be one file. So just use your netid, netid.p1. Do something that includes your netid in there. How's that? Anybody here have the same netid as someone else? Okay, so that should work. Yes? Go ahead. From to, yeah, move from to. Yeah. And you can look, I mean, I haven't gone over this stuff, but I've linked on the class page to tutorials about common commands that you can do under Linux and Unix, and so you can look them up. Yeah? No, no, no. I mean, that's kind of ambiguous as to what to do. I mean, if the TAs look at your code and go, by the way, this is really redundant and you could have shortened it, and they take points off, email me, and I will probably agree with them and, ruin the rest of your life is probably what will happen if that happens. So, yes, sir. Do you have to declare constants in the code? Yes. Uh-oh. Yes. Anything else? Last question. We have new stuff to learn too. Okay. I would suggest you look at the Nano tutorial. It's linked from the class webpage, and that will answer your question. Okay. All right. All right. So what's a program? A sheet or booklet giving the... Wait a minute. How did that get in there? Okay. Somebody tell me what a program is, because this is obviously the wrong definition. Yes. All right. It is an algorithm that's written such that a computer can execute it and a human can understand it. Okay? And you should know that by now. How many of y'all think that would be a question on the exam? No. Now that you're expecting it, it will never be there. Okay. So the last few weeks, here's what we've talked about. Last time we talked about Boolean operators. What is a Boolean operator? Yes? Yes, a statement that when evaluated always returns something that's true or false. Is that a candy thing too? Okay. We talked about switch statements. What does a switch statement do? Yes, sir. Yes, it'll allow you, instead of matching on a Boolean thing, to match out of a bunch of specific cases. The thing about a switch statement is you can only match exactly, right? You can't do less than, greater than. You can only match exactly. And you can only use numbers or single characters. Okay? And integers by numbers. I don't even think floats will work. Okay? So it has to be a very exact match. We talked about floating point numbers. Somebody name a data type that holds a floating point number. What? Float. What else do we have? Who said double first? Lost it. Okay, float, double, what else? Long double. We have, and what's the weird thing about floating point numbers? Yeah. Yes, they are not always that accurate because the way the number is represented in terms of a number of bits cannot always express exactly the number that we want. So when we work with floating point numbers and we do operations with floating point numbers, we end up with rounding error down at the bottom decimals. And depending on how much space you've allocated, if it's like a float, a double, or a long double, the lower decimals might be pretty close to the area that you're interested in the results. So you can get problems there. Okay? And this is why, in general, it's better to work with integers if you are not expecting a floating point answer, because you can do exact comparisons between integers. And with floating point numbers, you have to accept a certain amount of error. We talked about some other data types that go along with like integers. What else do we have besides ints? Short. What's a short? Shorter than integer. It's like half an integer. Oh, no, not cool. What else do we have? Yep. A long. What's a long? Double integer. What other kind of integers do we have? Yeah. Okay, we have character. A character is sort of an integer. What other type? There's one other thing I was looking for in here. Yes, sir. Nope. Integers. Integers. Particularly. What? What do we put in front of an integer to make sure that it's always positive? Yes. Unsigned. Okay. I bought this huge bag of candy and I've been remiss in getting it out, which means I've been eating it, which is bad for me. So, okay. And we talked about characters and characters. We mentioned this briefly. Character appear to you as a single letter, but they are really what? They're really an integer. And there's this code table that we map the integers to a particular character. It all happens in the background. You'll never see it. You should just know that, though, so that you know that a character is really an integer underneath, and we just treat it as a character. Okay. So that's everything we've talked about last classes. Everybody good on that? All right. I guess I should probably look at my notes and see what I'm going to teach today. Let's talk about some math. How many of y'all like math? Math is awesome. So, let's do some math. Let's work with some floating point numbers. And let's say we have double 64. We can often put a 0.0 after it. It's not required, but often when I create a number, I put a 0 after it. I need a name. What should we call this? 8 squared. Can't have that. So we'll have something squared that is 64. Okay? And we'll have another number, say double cubed, which will be 256. I probably need an equal sign in there. I'll put a 0.0 to indicate where influence. So I have a couple of numbers here. Okay? Yes, sir. Global variables for the time being do not exist. I will tell you how not to use them later. Okay? It's in the grading scheme. He might have talked about his section with it. Anything you declare, make sure it's within the brackets of int main. Okay? Yes? Absolutely. We could put them on the same line if we wanted, with just a comma between them. I typically do it this way myself. Again, you get to develop your own coding style. So. Yep. So. Sure. So let's just make sure that works. Where am I? Desktop. So we compile, and that compiles cleanly. So yes, we can do it that way. So there's all sorts of different ways you can do stuff. I mean, you can the comma doesn't matter. I actually, for my style, I actually just like putting everything on its own line, and that way later when I when I go back and read the code and I'm looking for something, I can just scan down the list really fast to see what's where instead of having to pick things out of groups. Yep. The computer has no idea of anything. So no. The computer knows that you have given this thing a name, but it has no idea what that name means. It has no association. Remember, the computer is just, it's like a giant grinding machine, except it grinds numbers, right? So, like when you have a grinding machine and I'm trying to think the things you grind, you put coffee in there, the machine doesn't know it's coffee, it just grinds stuff. And if you happen to put like lizards in there, it would grind the lizard right away, okay? I just say that because one of my best friends lives in Hawaii and he keeps finding lizards hiding inside his coffee grinder. And he posts the pictures to Facebook and he's like, this is why you always check your coffee grinder when you live in Hawaii, because otherwise you get some really weird coffee. All right, so the computer doesn't know. All it knows is that we're storing something double. It sets a bunch of space aside. There's a name and there's a value for it. Okay. So what can we do with these numbers? What do we know how to do? We can add, we can subtract. What else? Multiply. We haven't done much multiplication, but that's the star sign. What else? Divide. What else? All right, we've talked about mod, but here's the deal. Does mod work on floating point numbers? No, mod is for integers only. Okay, integers only. So I'm not sure, but we can try it really fast and we can say, let's put some double output. God, I hate doing this because, what ends up happening is that things change over time, or let's see if this works or not. I hope it doesn't. Okay. Yeah. So it says invalid operands of types double and double to binary operator mod. So what it's saying is it essentially doesn't, you can't do mod on floating point numbers, only on integers. Okay. So but mod exists. We know about mod as well. Okay. Say we go here and we do division. What kind of division is going to happen? Why? Because at least one thing is a floating point number, right? It will do integer division when both things are both things are integers. All right, so these are all the basic math operations that we have learned. And they're actually the ones that are built into the C++ language. There's a couple others we'll get to shortly. But these are pretty much all the math it knows how to do. Is this all the math you know how to do? What else do you know how to do? Exponents? Yeah. What else? Yes, functions of things. Cross product, you need arrays for that, stuff like that. But if this is squared, what does that imply? There's a root, so square root, right? So there's a bunch of other math functions that we know and we commonly use that we don't just have a simple symbol for. So we have two options, and I'm going to explain the options to you, and I will let you decide which is better. One option is we can use these basic math operations to write our own code to perform all these other functions. Like doing exponentiation, we can do square root finding. Wasn't there like Newton's closest intersect thing? It's been a long time from math from high school for me, right? Where you can estimate the square root. No? Somebody help me out here? Yep. So we could either write all the math operations we ever wanted just using this, or we could rely on code that people have written in the past to do this because we're lazy and we don't want to rewrite all the code ourselves. How many of you want to write all the code yourselves? I used to be that way too. I got over it. It happens. Like at first I wanted to write everything just because it was fun, and now I'm lazy. How many of y'all are lazy and just want to use the math? Yeah. So let's talk not about how to do it ourselves. Let's talk about using math. So first of all, let's revisit this thing up here at the top of the screen. Remember this #include IO screen? What was that? It's a library. Yep. And the libraries that we use all go up here at the beginning. So it turns out that we can #include something called, sadly enough, math.h. Now you might be asking yourself, why is the first one just IOStream and the second one is math.h? Why does the other one have a .h? Pardon? Close. There's different math things. Yes, sir. No, that's a good guess too. C++ is descended from what language? In C, when you include files, you use the .h. And so when people wrote C++, what they decided is, why recreate an entire C++ style library when there's an existing C library that works just fine for what we need? Does that make sense? So we #include math.h because that gives us essentially the C version of the library that we can use for math. Yes?
So you can include both libraries?
Yes, and in fact, our code has been relatively simple, but as we go out through the semester, the number of libraries that we will be including will be increasing dramatically. And you can include multiple libraries, whatever you want, to bring in whatever functionality already exists that you need. Okay. And this is good, right? How many of y'all how do y'all like being lazy? But lazy in a good way, right? Minimal effort, maximal results. Totally, I'm totally that way. So, and I'll just tell you as an aside, later when you're programming and doing a lot of programming, most of your time programming will not be spent doing what you're doing here. Most of your time will be spent looking up libraries that already do what you needed to do and figuring out how to glue them all together, and then writing the smallest amount of code possible to bridge the gaps between the libraries. Okay? However, in order to get to the point where you're capable of doing that, you have to understand the basics and how the other stuff works first. Does that make sense? So programming changes over time as you move away from doing things yourself into using other libraries. Okay, so here we are. We include math.h, and that gives us a number of different functions. You can find out what functions are in there a couple of different ways. Here's what I did. I searched for C++ math.h functions, right? Because it's pretty common. And the first hit is essentially this page that gives you, I can't increase the font, sorry about that, that gives you a huge list of all the functions that are included in there. We've got trigonomic functions, hyperbolic functions, exponentiation and logarithmic functions, You got power functions, error and gamma functions, rounding, floating point, minimum, maximum, and other stuff as well. Okay, so this library includes for you a ton of different things that you would like to have. Does that sound good? All right, so let's just take a look at the list and let's see if there's something in here that looks good. How about this one, square root, SQRT? You like SQRT? Let's figure out the square root of something. Anything in there you want to figure out the square root of? Thank you. Oops. So what we can do is we can say the square root is equal to SQRT, and then in parentheses, the thing that we want to take the square root of. Okay? In parentheses. This is called a math function. We are doing a math function call, and we will learn later how to write our own functions. But for now, what you need to know is that the function has a name, and then it has parentheses, and it has what are called arguments inside there. This particular function only takes one argument, which is the variable you want to figure out the square root of. All right, does that make sense? All right, let's just see if this works. All right, one of the things I've been telling people is it's always good to compile your code every so often as you go along to see if you've introduced mistakes. Shall we take a look and see if we've introduced any mistakes here? Does that sound good? So I will go back. Here we're going to compile again. And it worked. Okay, great. I did not expect that to work. Okay, so it worked on my machine, which is weird because it does not work on my desktop machine, which is a Mac running exactly the same operating system. Which means I have a different compiler version in there somehow. Okay, here's the deal. Sometimes when you compile this, you will get an error message. Okay, not on my computer, but on other ones. Yeah, I don't have good networking in here, so I can't test. I cannot easily demonstrate this to you. But sometimes when you compile this way, you will expect it to work, and it will not. It will fail. And here's why. Remember that when we talked about math.h being a C-style library? Well, it turns out the old C compilers needed some special information. And they needed to have on the line that did things, oops. They needed this. At the end, you needed to add a -L math. And you can think of it as that stands for load the math library. Okay? So some C++ compilers, including the one on my desktop at home where I tested this the other day, need you to have this -lm when you compile. Your compiler may or may not. I don't know about CS class off the top of my head, but your compiler may or may not require that. Yes, sir. It will tell you that it cannot find the thing called square root. It will just say, I have no idea what SQRT is. You're an idiot, leave me alone. Right? So I was hoping I didn't test this on my laptop because I assumed that since I'm running Macs and I keep everything updated, it would be the same from machine to machine, but clearly it's not. So if I compile it, it probably won't give me an error. It'll still compile. It's just that this compiler does not require that -lm at the end. Okay. As you're going along, if you start programming other stuff, the -lm is kind of the irregular verb of compilers, right? You all familiar with irregular verbs? Somebody give an example of one. To be, are, am, was, I don't even know, right? So, but this is the irregular verb of compiler stuff. Occasionally you will find a library that requires this, okay? Occasionally. And it gets complex, a little bit complex sometimes. Yes? Yes. This is specific to things that use math.h. There are some other libraries that we will not use in this class that sometimes require a similar thing. So for example, there's a crypto library for doing cryptographic operations. You can put crypto.h in your program and you have to do -l crypto on the compiler line for it to work. That's the one that I end up using relatively often, so that comes to mind. Yeah, Helen, you had a question?
So can you have another operation within the square root?
Sure. So that's our questions. Okay, so everybody good with that, getting this to compile? Right? If you're using the math library and you run into an error, you might have to add the -lm. All right? Everybody good with that? All right. Let's stand up for 1 minute, shake, stretch. I've been talking for a half hour. That's too long. All right. So here we are. We've done this. We've seen it's compiled. If we ran this, what output would we see? Why? Because we haven't, in our algorithm, told it to output anything. So let's output and see what we got. All right. Now you see what happened here is that I went past the edge of my screen and it kind of wrapped around. That's my indication that my line is probably too long, and what I normally do then is I break it into two. And a line like that. Okay. All right. So now we have some output. Let's compile it again and see if it still compiles. It does. Whoops. Let's run it. Somehow I named it mathc by accident. It says square root of 64 was 8. Is that correct? Yes, it is. Okay. Yes? Yes. We're just going to ignore that fact, that it could also be -8, okay? Because this square root just gives you the positive squares, the positive part, okay? We could also figure out the negative part as well. All right, so everybody good with this? So the question I had before is, could the square root be operated on a variable, or could we do some other stuff in there as well? So let's try this. I've modified our square root program. Instead of just computing the square root of squared, I'm telling it to do squared times cubed. Okay, squared times cubed. Yes? Yeah, don't worry about the colors. It got a little confused. Okay. My editor changes things to colors, and every once in a while it gets a little bit confused. That's all. And I could explain to you later in the semester why it turned that particular color, but I won't. Okay. It's a little confused. All right, so here we are. We're now computing the square root of not squared, but squared times cubed. How does the computer handle this? It does. It looks at it and goes, okay, I have to figure out what this side is so I can assign it over on the other side of the equals. And, oh, there's stuff in parentheses. I will do this stuff first. Squared times cubed first. And it'll compute it and print it out. And what's the answer going to be? What's that? Okay. Now, of course, our output is wrong because we were no longer computing the square root of 64. We're actually computing this 64, times cubed. So we can change that in there as well. And now when we recompile and run it, it will actually say 16,384. Yes? Okay, So the question was, inside the parentheses, you can have as many arguments as you want. The answer is not really. And we'll see later that we'll have a specific number. This is really only one argument right here because we're telling it to do some math, and then once you figure out the math, do that argument. Does that make sense? If we wanted to do something else, and let's just go take a look at our math functions. We might choose something like power. Oh, good, I have a network connection. And essentially what power, if you look at the sample code for power, it takes 2 arguments because it has what number and what number you're raising it to, and you separate them by commas. So let's try this. We'll create a variable called power. We will say power is equal to pow of, let's say, squared. Let's raise cubed to the squared. Otherwise, we're going to get some pretty big numbers. So here we have 2 arguments separated by a comma, right? And if we output this, we'll see what the result was. Okay. Everybody with me? So this is how to use a math function that has 1 argument. In this case, the argument is computed by the computer before it's used. This is how to use a function that has multiple arguments. You separate them with a comma. Okay. There's a question? Yeah.
So cubed is what you're raising?
Yes, we're raising cubed to the power of squared. So 256 to the 64, which is going to be what? Big. Wait, are you using a calculator? Did you use a calculator for that? Oh, okay, good. Because if you were able to do that in your head, you totally should have won the addition thing we did on like the second day of class. So all right, so let's see what's going to happen now when we compile. Compiles cleanly, that's good. When we run it, we get a really big number, 1.34078 times 10. This is scientific notation, so it's 10 to the 154th power. It's a big number. Sir? There are maximum numbers, and it depends on what you're using. So, yes. And I haven't showed you how to find those, but you can find them. All right. Everybody kind of good with the math stuff? Yes? Yes? We good? All right. I want to show you one other thing really quickly. All right, so here's a new CC program. I've made a little template so I don't have to type this stuff out all the time. So let's say that we have like int x equals 0. And what we're going to do is we're going to be counting a number of things. Okay? Oftentimes the computer is used, if you're going through and you're counting things, to count, because the computer is very fast at that. Let's say that we had like a giant file, and we were reading the file 1 line at a time. And the file was, the giant NSA database that they've kept about every single phone call in the United States over the past 5 years. And in that, you had several billion entries, and you wanted to know how many entries were in there. Okay? So you start reading the file, and every time you see a new line in the file, you count that line. Does that make sense? Everybody with me? So when we count a lot of stuff, what we often do is we do something like x equals x plus 1. So every time you count something, we're going to do something like x equals x plus 1. This is very common. Doing this operation is super common, and you're going to start seeing it over the next week or two, where we're counting things. Because it's common, and because computer geeks are lazy, there is another way to express this. One way you can, there are actually several. One way you can express this is just like this. X plus equals 1. And what this says is x gets equal to itself plus whatever is on the other side there. It is exactly the same as saying is this thing up here. Does that kind of make sense? So let's put some output statements in. And I know I've gone fast through this, so let's just step through our algorithm. Int x equals 0. What does this do? Declares what? Of what type? Whose name is? And the initial value is? Great. What does this do? And what value is x going to have right here? Good. What does this do? It says, oh, I have an equal sign. I have to do the stuff over here first. It gets the value for x, which is? Adds what to it? 0 plus 1 is? And then it stores the results back in. So we output x here, and what value does x have here? Great. Now down here, what happens? Sort of the same thing, right? X plus equals 1. What plus equals 1 means is get the current value of x, which is? Add this number to it, which is? 1 plus 1 is? Except for very large values of 1. That's true, right? 1 plus 1 is 2. And where do we put that 2? Back in x, okay? So this should print out what there? And should print out what there? Print out what there? All right, let's see if that works or not. So I'm compiling. I created this program called add assign, which is stands for additional assignment. It compiled cleanly. And if I run it, 0, 1, 2. Everybody good with that? Yes? Yep. Yes, you can. And we'll get to that in just a second. Oh, because here it was 0. Here we added 1 to it. And so what is x right here? Now it's 1. And down here we added 1 to it once more. Yes, the assignment operator means whatever math we do here puts it back. Yep. Does that make sense? Okay, so this is common. People do this a lot. Everybody good so far? Yes, sir. Okay, we'll get that. So with these, we can do plus. We also saw what? Minus, division, right? It turns out you can use the same notation here too. So you could, if we wanted to do x minus 1 down here and take away the one we did above, we could just put a minus sign there. Right? And we compile and we run it. We will see that it goes up to 1 because we add down 1 to 0, which matches our code. We start at 0, output, add 1 right there, output, subtract 1. It also works for multiplication, and it also works for division, and I believe it works for mod if you have integers. So you can do all that in one step. This is probably, the plus is almost always the most common way to do that. In fact, it's so common that there's yet another way to write this expression. And here's how you do it. Just like that, plus, plus. This is called the increment operator. And what it will do is it will say, take the current value of x and add 1 to it and store it. Programmers are lazy. This is the easier way to write it. Yes, sir. And this is the joke in C++, right? So C was the original language, plus plus, increment C, C++. Yes, except for your grade, yeah. No. I don't want to, I don't think so. Some languages have constructs like that. I'm not sure C does. I'm not sure. I don't think that'll work. I've never encountered that if it works. If it does work, it's not in common usage. That's it. Yep, which is equivalent. All these three things do the same thing. Okay. Yes, sir. Yes, and if we wanted, there's the decrement operator. But there is not there's not like multiply or divide. So there's no like slash slash. Yep. Yes, it increments things exactly by one and one only. And the reason is that it's super common to do that. Like when you're reading programs, it's so common to like, and you'll see later as we go on in the semester, we'll be using this pretty often. All right, everybody good? All right, so the thing about x++ is this. It's often used like this. Often used like this, where you increment and like print out or do some operation at the same time. Okay. Now, let's think about this program and figure out what it's going to print out. Okay. I'm going to get rid of the decrement because we're not worried about that right now. So what is x when we start? What do we print out here? What is x after this line is executed? What do we print out here? What is x after this line is executed? What do we print out here? What is x when this line is executed? And what do we print out? Why don't we try it and see? So the question is it going to print out x and then increment it? Or is it going to increment it and then print it out? What do you think? How many think it's going to increment it and then print it out? How many of y'all think it's going to print it out and then increment it? How many of the people have their hands up at program before? Okay. Let's test it and see. Whoops, it would help if I compiled it, wouldn't it? So we compile it. Now we're going to run it and see what happens. 0, 1, 2, 2. Well, that's weird, isn't it? Let's go back and look at our code. 0, we start at x equals 0. So we expect this first output to be, this one increments the x by 1. So we expect this one to be, this one increments it by 1. So we expect x to be, it prints out 2. This one prints out what? That's weird. I'll tell you what. Let's add one more cout statement right after that and see what happens after that line. Okay? You ready for this? 0, 1, 2, 2, 3. 0, 1, 2, 2, 3. So what happens is this one's 0 as we expect. This one's 1 as we expect. This one is 2 as we expect. This one is 2 again. But this one's 3. So what this means, what this plus plus after the variable name means is use it, and when you're done using it, increment it. Okay? Because what it looks at, it goes, oh, I have to increment it, but I have to print something out first. So it prints out the current value and then increments it. And then the next time we look at it, it is 3. Yes, sir. Mm-hmm. Yes, I'm trying to show you a very specific strange behavior of this operator. Yes, this is different in that this plus plus operator doesn't just increment it, it uses it first for whatever purpose, in this case output, and then increments it. It uses it first and then increments it. Yes, sir. Yeah. Yeah. Right? It uses it and then that. So if we did something down here, if we did like another +1, it would increment it again. Right. So at the end of this line right here, my hand is between these two lines, x is 3, before the next line. Even though it printed out 2 on that line, once that line is done, it becomes 3. Yes? Why would you want to do that? In general, I do not want to do that. And in general, I don't do that. And the reason is because it makes your code a little bit harder to read if you're doing it. It's a very common notation, and some people use it to condense their code. I am not in favor of that because it makes the code harder to read, because you have to figure it out. But let me show you what I am in favor of. How about this? How about taking this plus plus and moving it from after the x to in front of the x? Anybody have any idea what this is going to do? Yeah? Yes. If the plus plus is before, it says increment it first and then use it. If the plus plus is after, it says use it first, then increment it. Does that make sense? So let's run this and see what happens. We'll compile it. It compiles cleanly without errors. We run it. And now look, now we get what we expect. 0, 1, 2, 3, and then 3 again. Because this time using it first says now increment it to 3 and print it. So you use it before you increment it. Yep. Yes. There are many ways to write the same thing. And you look confused, but if you think about it, English is the same way. We have many ways to say the same thing. There are multiple ways to say express similar ideas, right? We can come up with a whole bunch of different ways to do the same thing. I just want you to be aware that these exist. They're very common. I will use this notation later in the class for 2 reasons. 1, because it's convenient, and 2, because it makes for some incredibly difficult exam questions. Okay. And it used to be, let me just tell you how hard it was in the old days. It used to be you could do this. But now they don't let you do that anymore. In fact, you used to be able to do this. And this was actually considered legitimate, and this would do a whole bunch of computation and come out with something. Okay. You can go, you're not going to disturb anybody. But they changed the compiler because people were using this in horrible, horrible ways that made your code horribly unreadable. And you know what? It killed like a bunch of my exam questions because I had some really good exam questions that depended on which went first and after. So it was sad. It was a sad day. But it's better for the language. All right. So we've covered these additional assignment operators, right? This type of thing is very common. You can shorten it by using plus equal. You can also divide equal, times equal, whatever you want. And then the increment and decrement operators, because, by the way, everything that works for plus plus also works for minus minus, right? You can do minus minus x or plus plus x. You cannot do multiply multiply x or divide by x, but only plus plus or minus minus. Okay? And the minus minus works the same way. This one right here, x minus minus, means use it first and then decrement it. Minus minus x means decrement it and then use it. Now the question is, when would you commonly use that? It's very commonly used like this by itself if you just want to increment or decrement something where it's not being used first. Does that make sense? Like here we're decrementing it, but we're not like trying to output or put it as an argument to a function or something like that. All right, everybody happy so far? Who's unhappy? Nobody's unhappy at all? You're unhappy? You're like the one person I don't really care about, so no, just kidding. Here. All right. Okay. So everybody's good on this. Let's move on to the next thing. I'm going to switch back to, let's make a new program. That way I can upload it to Blackboard. Separately. All right, so let's say we have some variables. Int x equals 12, int y equals, what's your favorite number, somebody? 4. Okay. And we're going to use some math stuff here too. So I'm going to go back and pound include. What do we use for math? I can't remember. Math.h. Okay. Oops. 12 and 4. All right. And let's just have int z, and we'll set this to 0 so we can do some stuff. Okay. All right, so let's say we have something like z equals 5 minus 2 times y plus square root of, let's make x a double. Sorry. Let's make z a double. That's much better. Okay. Times the square root of x. Let's make x 16. That'll be easier to do work with square roots, right? Okay. So we have double x equals 16, int y equals 4, double z equals 0, and we're going to do z equals 5 minus 2 times y plus the square root of x. What is this going to output? Exactly. It is not going to output anything, because we did not tell it to. What's it going to output now? Yes? Yeah, question. Uh-huh. No, I forgot. It's just a convention. It doesn't matter. The compiler is going to be happy either way, I believe. Yeah, the compiler is happy with it. It's often a convention just so that when people are looking through the code, it helps point out that that's a floating point value, right? Because when we look at that, we can tell without having to read the type that it's floating point, because that won't work within it. And I am inconsistent about how I do this. And the reason is I don't do it in my own code, but I'm trying to promote good habits for you. It's like the difference between what I do when my kids are around and they're not. So, okay. All right, so now what is this going to output? 1, 5 minus 2 times 4 plus 4. All right, how many of y'all have seen these things going around Facebook where they have like the big math thing and you're like, what does this print out? And if you don't get 4, then you don't know anything, right? A 5th grader could do this. So the answer is that what is the precedence of operations if you're doing math stuff? What is the precedence in the computer? And the precedence is essentially probably the same as you learned in high school. Did you learn something in high school? What? Rah, 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 rah. Just somebody shout it out loud. One person. Who's going to shout it out? All right. I have it as, please, friends, excuse my dear Aunt Sally. Right? Please, friends, excuse my dear Aunt Sally. And here's why. The precedence goes like this. First, parentheses. Second, functions. Third, exponentials, which, by the way, C++ doesn't have. How does C++ get them? Yeah, because there's a function. But in most other computer languages, it does. Multiplication. Or division. Addition or subtraction. The big wizard. It's magical. It just works this way. I honestly don't know. It's just the way it's like just kind of how it works. I won't get into. There's a whole bunch of other math stuff that I won't get into because you all don't care, and I'll just confuse you. Okay. So here we can use this. So parentheses. Where do we find parentheses? Well, we don't have any, right? The only one we have is in the function, and those don't really count. So the function's first, which is square root of 16. What's the square root of 16? 4. Great. Exponentials. Do we have any of these? So we have 5 minus 2 times y, which is what? 4 plus 4. So we get 2 times y, which is 8. Right? And then from then it's left to right. Right? So it works across. Now, yes, sir? Okay. So the answer is probably 1. I probably don't even know what it is. Right? I don't care. Here's the thing. Don't write your code this way. How many of you are going to be able to remember this all the time? Parentheses, functions, exponentials, multiplication, division, addition, or subtraction. It's going to matter. We might give you a question on the exam to do it this way, and I'll probably give you some practice questions about it. But here's what you do. When you write your code, don't do this. Don't do it. Here's what you do when you write your code. You ready? You put parentheses in to force the operation to evaluate in the way that you want. Just put them in. So what do we want to do? Let's say we want the square root to execute first. We do that. Let's say we want to do, y plus the square root next. And then we want to do 2 times that next. And now we're good. Now we have forced through parentheses the execution of the operation in the way that we want. Okay? Yes, sir. So I would suggest you do this because this is actually easier for people to read, right? Strangely enough, you don't have to remember any rule except this very first one, parentheses first. So what's the innermost parentheses? Yeah, we go 1, 2, 3, 1, 2, 3, up, right here, square root. What's the next one? Y plus. So it's better for you to write your code forcing evaluation of things in the order that you want. That being said, not everybody writes their code that way. There may be times when you're reading code that you will see people who did other stuff, and you should remember that. Please, friends, excuse my dear Aunt Sally. Question? We can force it to evaluate in different ways depending on what we want. I actually didn't have any particular outcome designed for this equation, right? This is a made-up example that isn't computing anything real. It's just to show you that if you put the parentheses in, you can force evaluation the way you want. Okay, does that make sense? So you have control, and instead of depending on this, which may or may not be the way that you want it to do, just put a bunch of parentheses in. Got it? All right, stand up, stretch, wiggle around for like 1 second. Yes. Double colon? I was hoping not to have to ever explain that. Do you want to come to my office hours and I'll tell you? Wait, you're doing research with Grace and you're in this class? Ask her what the double colons are. All right, this is all going on the record, by the way, so. How can, all right. All right, welcome back. How's everyone doing? Happy, we're happy. How many are happy? How many are sad? How many are in a state of numb despair? Does that describe someone? Okay. All right, so we've been talking through class about different variable types, right? Name a type that we can have. Double, what else? Int. 2 more that we've used. Character, yeah, long double. And 1 more basic type? Boolean, okay? So our basic types are int, character, float, and Boolean. We have kind of extended types, double, long int, unsigned int, short, which we'll never use. Unsigned character you can have, and that's actually very useful in some situations. I don't want to make fun of it. It's just we'll never use it in this class. Okay, how many of you have a name? Anybody have a name in this class? How many of your name would fit into one of these data types? Anybody here named X? X? No? What are we missing? we are missing the ability to put a whole bunch of characters together, right? My name is not C, it's Clay. That has 4 characters. It would be really annoying to just have one character name. So we need a way to put multiple characters together. And we have this, and this is called a string. It is referred to as a string because it is a string of characters. Okay? It is a string of characters. Now, C++ by default does not include strings as a data type. It does not. What do you think we're going to have to do to be able to use strings? Well, add a library. Most of the additional functionality that we get is through libraries because we are lazy and we don't want to write our own. So, to use strings, pound include, anybody want to guess what this is? Just string in this case. Now, we had the .h with math. Why was that? Because it was C. This doesn't have a .h, and why is that? C++. C++ strings are different than C strings. They are better. They are significantly better. They are relatively fantastic compared to C strings. Okay? How many of y'all ever worked with C strings? Anybody programmed before? You're done. Just never do that again. Okay? Just don't do it again. C strings are so much better, and I'm not even going to explain why, but they're a lot better. We'll find out why later. Okay? I'll explain why later. But for right now, we're just going to use C strings. So once we have pound included string at the top, we can now define things as a string. Notice that what I've done is I said string, which is the type, name, which is the name of the variable, right? And I've defined it as a literal saying Clay. So what this does is it says, hey, go off in memory, find a box or more boxes because it's going to take several memory slots to store all this stuff. The name of that is going to be name, and when you initialize it, put Clay in there. So what do you think is going to happen if we do this? Cout. Yeah, it should print out Clay. So let's just test and make sure I haven't screwed anything up. And that worked. Okay. So strings. Strings are incredibly useful, right? They're incredibly useful. We're going to end up using them quite a lot. Now, yes? Do you work on like the psychic hotline when you're not here? Because my next statement was going to be, do you think that you can have a switch statement with a string inside of it? How many of y'all think you can switch between strings? How many of you think you cannot? How many of you are not sure? Somebody who says you cannot, tell me why. Yes? That's true. It's true you can only use characters. It's true I said that, and that's the reason why. But the real reason why is that if you remember, a character is actually an integer underneath, right? It's a code table. A string is not that, which was the question you were asking. It is not an integer underneath. It is actually a collection of characters that are glommed together. So it is not represented by a single integer. So you cannot use a switch statement on a string. Okay? You cannot use a switch statement on a string. Does that make sense to everybody? It's annoying. It would be nice if you could, but you cannot. Question? A string is a collection of characters, which are secretly integers. Characters have secret life as integers. Okay? It's like the character is their superhero identity, and the integer is their boring undercover identity, their secret identity. Okay. Does that make sense? We cannot switch on a string, which saddens me. It would be nice if we could. Okay, so here we created a string. We initialized it all at once. We could do something like, string office phone see, you confused me. I misspelled phone because I was too busy. Right? So we could say string office phone. We could say office phone. How do you think we set this thing? All right, so there's my office phone. We can set it. Let's just see if that compiles cleanly. It does. It seems to be working, right? Okay. We already saw how to output, so we can output office phone as well. Yeah, I'm going fast. Do you have a question? Nope, I didn't. Yes, I was just showing you we can do whatever we want. In this case, right, with clay, right here, I created it and initialized it in one step. Here, I created it but did not initialize it and changed it down here. I reset it down there. You can do work. Now, let me ask you a question. Throughout this class, I have been pretty careful when I create a variable to initialize it to something. I did not initialize the string here. Okay, I did not. Anybody curious why? Anybody want to guess why? Why? Because the magic that's included inside this string library will automatically initialize a string for me. Okay? When I declare a basic type, I'm at the mercy of the computer. It will give me a box, and if there happens to be something in the box, that's what I get. But because strings are written as part of a library, whoever wrote the library included the part that when the string is created, it is automatically initialized to an empty string, essentially. Okay? So strings we don't have to be as paranoid about initializing because the library does that for us. All right. All right, questions? Yes? No. As long as they're at the top, the order does not matter. They don't have to be alphabetized. There's no dependencies or anything like that in general. Yes? No, the library must be at the top. And that's a compiler convention because when the compiler runs through, it looks at all the list of stuff it needs and then does its magic to make sure it has those before it does anything else. So you can't just like put something later on. Or who knows, maybe you can, I don't know, but the convention is to put them all at the top. All right, so there's a lot more to tell you about strings, more than I could do in a minute and 30 and 20 seconds. So how about we do it on Thursday? Oh yeah, and so what I wanted, one thing I forgot, you can also have const strings, you just have to put const in front of them. And if you're going to display a message, a particular message, like, I don't know, something with % signs in your program, you can have a const string result in there. Remind me next class. Yeah, okay, hey guys, wait. I've been asked one question. I want to show you something really fast because I meant to earlier. And it'll actually help you if you're doing all your code on so here's all my code, and I've taken out all the formatting, right? Do you see that? There's a program on CS class which is called indent. So if I output my my code really fast, whoops, I outputted the program, the binary program, you can see it's not formatted, right? Well, check this out. If I type indent string.cc, it apparently does nothing. But now when I show you the code again, it automatically reformats your code. So if you are coming into annoyances with formatting your code, you can use the indent program to automatically format it for you just by typing indent and then the file name of your code, and it'll do some formatting automatically.